13. Multiply fractions. We are shifting gears from chapter 4. We did a lot of adding and subtracting with fractions. To chapter 5, we'll do a lot of multiplying and dividing with fractions. Much like integers, positives and negatives, some students prefer the multiplying and dividing to the adding and subtracting. What was the main rule that you had to follow when you added and subtracted fractions? In order to do so, they had to have what? Common denominators, right? When you multiply or divide, okay, the rule is everything has to be in fraction form. And what I mean by fraction form, sometimes it's called A over B form. You need a numerator and you need a denominator. It doesn't necessarily mean that the fraction form has to be like regular fraction. We could say improper fractions would also work because you have one numerator, one denominator, okay? And oftentimes we will use improper fractions, okay? But that's the main rule, is just to make sure that everything is in fraction form, okay? So if we take a look at an example, and we say, all right, 5/6 times 1/2, okay? When you multiply with fractions, essentially what you do is you multiply straight across. 5 times 1, 6 times 2 is 12. Before I circle it and make it my final, I have to ask myself, is that fraction in simplest form? 5 and 12 have anything else I can divide them by besides 1? They do not. Therefore, 5/12 would be my final answer. Okay? So yes, you will multiply the denominator when you added and subtracted. You pretty much got the fractions to have those common denominators, and you left the denominator alone after that point unless you had to simplify. But here, we will multiply if necessary. Any questions so far on the basics? Okay. Well, I'll give you a couple of examples. 3/5 times 1/4, 2/9 times 5/7. All right, Josiah. First one, 3/20. Good. Agreement? Next one. Trinity? 10/63. Agreement? Awesome. Good. See, not so bad, right?
That's all we gotta do.
Well,
We don't gotta simplify.
well,
Yes.
well. Right. So, if I were to have a problem like this, 1/5 times 5/8, and if I were to go through and just multiply as is, I would get 5 on the top, 40 on the bottom, which simplifies to 1/8. Now, there is something that I'm going to ask that you do, and not, this isn't like optional when we get to this situation. Take the same problem, but sometimes we can do our simplifying before you do the multiplying. I look diagonally. 1 and 8. Do they have anything I could divide them both by besides 1? 1 and 8? 5 and 5, I can divide them both by 5. So 5 divided by 5, 5 divided by 5. Now we multiply with what's left, 1 times 1, 1 times 8. I did my simplifying beforehand, therefore then I don't have to remember to do it at the end. Now sometimes you still will. Simplifying ahead of time doesn't guarantee that your fraction will always be in simplest form when you multiply, but you give yourself at least a pretty good chance. Okay? So let's take a look at another one. 2/9 times 3/8. So again, first thing we're going to do is look diagonally to see if we have anything in common where we can simplify these either numerators or denominators. 2 and 8, they're both even, which means I can divide them both by 2. How many 2's are there? How many 2's are in 8? 3 and 9. Both have what? 3. How many 3's here? How many 3's? So 1 times 1, 3 times 4 is 12. Otherwise, if we wouldn't have done that, you would have gotten 6/72. And some of you, not that that's an impossible fraction to simplify, but you know yourselves, you look at that and you look at the 72 as a denominator, and half of you would rather just circle it and call it final than go through the work to find out what it really is. So if you do this, it really saves you a lot of time, and it also saves you in the end to make sure that everything is simplified the way it should be. Okay? So I'll give you a couple to try like that. Whoops. That's a 3. 4/9 times 3/10. Looking diagonally, 3 and 9, 1 and 3, 4 and 10. Anything I can divide them both by? 2. So 4 divided by 2 and 5, therefore 2 times 1 and 3 times 5, 2/15. Did we all catch the 4 and 10? Okay, make sure you catch the 4 and the 10. 7, 4, nothing. 3 and 15, 3, right? 7/20. Okay? So not so bad. Like I said, a lot of people prefer the multiplying over the adding and subtracting. Okay? There are some that you have to be aware of. Like, okay? Now, the rule is everything has to be in fraction form. So the 5/12 already is. And anytime we want to put a whole number into a fraction, 30 over what? 30 over 30 equals 1. 30 over 1. Because if you think about it, as an improper fraction, if we were going to put this back into a mixed number, how many times does 1 go into 30? 30. Hence the whole number. Okay? So now, you just treat the problem like you normally would. 30 and 12, they're both even. We'll start with the 2 and say 15. Anything else between the 15 and the 6? 3. Okay? 5 times 5. 2 times 1. 25 over 2. 2 into 25. 12 is 24 with 1 left. 12 and a half. 15 and 6 both have 3 in common. So 15 divided by 3 is 5. 6 divided by 3 is 2. Okay? So 12 and a half. Now, think through it logically. 5/12. If this were one of those rounding that you saw on your test, like in that first section, is 5/12 closest to 0, half, or 1? Half. What's half of 30? Okay, so we had 12 and a half. Close enough to 15. This isn't actually half. It's a little bit under half. So we're going to get a little bit under 15. Okay? So you can estimate, you can check it out and make sure that you're at least in the same stratosphere. Okay? We need to put it in a fraction form when? Brandon, when we do the work. How am I going to put 28 as a fraction? Okay. Now everything is in fraction form. Okay. What happens after this? Let the chips fall where they may. 28 and 14 both have 14, right? There's 2 there, 1 there. 11 times 2, 1 times 1. Okay. He had his left like this. He said, I thought you were supposed to leave everything in fraction form. Well, you have to simplify. So you cannot leave. If you saw any other improper fraction, you would put it into a mixed number. So the same thing here. How do we get the whole numbers to be fractions? We put a 1 underneath it. So 22 over 1 is just simply 22. Because 1 goes into 22 times with 0 left over. Okay? So 22 and 0 over 1, you don't need the 0 over 1. Just use it as 22. Okay? Some of these we can find using mental math. 1/4 of 44. Basically what we're doing is you're taking the 44, and can you divide it by 4? 11. How many of those 11s do you need? Therefore, it's 11. Same thing here. If you did 2/7 times 63, 63 divided by 7, 9. How many 9s do we need? Equals. If 1/7, if you take 63 and you get 1/7 of it, which makes it 9, we don't have 1/7, we have 2 of them. So if 1/7 equals 9, 2/7 must equal 18. Now if you can't get it using mental math, then by all means, you can set it up and just do it the way you're supposed to. 63 and 7, we already said they have 7 in common. What's 2 times 9? 18 over 1, which is 18. I mean, you can take that road if you want, if that makes it a little bit easier for you until you get more familiar. Okay? I have for you your worksheets for Chapter 5. And I will hand them out to you at this time. You have plenty of time to get started on your assignment. Okay? -2. We got all this extra time. I might as well use it wisely because you're nuts. Let's do a warm-up. And let's revisit the estimating. Last chapter, when we rounded mixed numbers, we rounded them to the nearest whole, and we looked at the fraction and said, has to be half or bigger. 5 and 5/6 would round to 5 or 6. 6, very good. 6 and 4/9 would round to 6 or 7. How does 4/9 compare to half? Greater or less than half? Less, so it's going to stay at 6. 6 times 6, I should get something in the neighborhood of 36 when I estimate. Okay. If you were to see 1, 7 and 11/16 times 7 and 1/5, if I were to estimate here, or round, 7 and 11/16 rounds to 8, 7 1/5, I should get something in the neighborhood of 56. Now, that might not be something that you have to do all the time, but when they ask you for it, that's what you'll have to do. Plus, it helps if you're not really sure that what you came up with was right. You can go back and estimate and see how that compares to what you got. 1 1/4 times 2 3/4. The number one rule that we have when we multiply with fractions is everything had to be in fraction form. Are these numbers currently in fraction form? So I need to put them into fraction form, and mixed numbers will turn into improper fractions. So 1 times 4 plus 1, 5/4. 2 times 4 is 8 plus 3, 11/4. Use their same diagonal trick to see if there's anything in common. 5 and 4 have nothing. 4 and 11 have nothing. 55/16. Can I leave it that way? No. Improper, I have to put it into a mixed number. 16 goes into 55. 3 times is 48. Take 48 away from 55. 7. 3 and 7/16. If we go back and use our estimation trick, we would have 1 times 3 to give us something in the ballpark of 3. We came up with 3 and 7/16. I think that's close enough. Okay. So mixed numbers need to be turned into improper fractions. So try this one. 7 1/3 times 3 and 3/4. Let's go ahead and just estimate real quick. 7 times 4 equals 28. I should get something in that neighborhood. Fraction form. 7 times 3, 21, plus 1 is 22/3. 12 plus 3, 15/4. Use the diagonal trick. 22 and 4, they're both even, right? So I can cut them both in half. 11 and 2. 15 and 3 both have 3 in common. There's 5. There's 1. 55/2. If you don't know, then by all means, set it up. Okay? Set it up. If you can't do it in your head, that's okay. 2 times is 4. Into 15 is 7. 1 left. 27.5. How does that compare to 28? Pretty good. No, 28 is just the estimate. 28 is just giving us the idea of what it should be, or where it should be. Okay? Ten and 4/5 times 1 2/3. Give it a shot. Estimate if you... 10 times 5, 50. 54/5. 3 plus 2 is 5/3. So 5 and 5, those become 1s. 54 and 3 are both divisible by 3. Okay, so what is 54 divided by 3? 18. 18/1 is equal to 18. Now, if you didn't see that, and you ended up with 54/3, you would still get 18 if you simplify. What does the estimate say? 11 times 2 equals 22. So this is an over. You went over on both of these. You went from 10 and 4/5 up to 11. You went from 1 2/3 up to 2. This estimate's going to be a little bit higher than your actual is going to be. So don't worry too much if it's, you know, a couple off, but 18 is what we're looking for. Okay? How do I get what? Because we need to put this into fraction form. 1 times 3 plus 2, 5/3. We multiply the whole number in the numerator or denominator. We add the numerator, and the denominator stays the same. Destiny, question or just? Let's see. Take out 5-2. One through 36. Numbers 1 through 9 tell you to do what? Estimate. The rest of them you have to find the product. Yeah, 1 through 36 actually. I gave you a break in the last two. So, all right, now that since you have double, maybe we'll use our time a little bit more wisely the next 20 minutes.